I just had to let you know you're.
Assalamualaikum and good day everyone. We are Group 3 from the Engineering Mathematics DAE12003 course. My name is Muhammad Denis bin Johan and matriculation number is AA251082. The other member of our group are Muhammad Faris Najmi bin Muhammad Faizal AA251615, Syahmin Muiz bin Muhammad Nazri AA250460, Muhammad Hadif bin Muhammad Fakri AA250342. Today, we are pleased to present our PBL project. We hope you find our presentation informative and thank you for your attention. Okay, first is problem background. In this study, we examine two industrial applications that involve quantity changing continuously over time. The first application is an industrial tank drilling system, where we analyze the change in liquid volume to determine whether the tank is filling or emptying at a specific moment. The second application focuses on a chemical reaction process, where change in the concentration of reactant are studied to evaluate the reaction behavior and improve production efficiency. By applying the concept of differentiation, we can calculate the instantaneous rate of change of both the liquid volume and the reactant concentration. This result help engineers understand the performance of industrial system, predict future behavior, and optimize industrial process to achieve better productivity and more effective operational control. With that, let us begin our presentation.
Assalamualaikum warahmatullahi wabarakatuh. Nama saya Muhammad Hadif bin Muhammad Fakri, nombor matriks AA250342. Jadi, untuk part saya akan menerangkan tentang key formulas, definition and mathematical concepts. Okey, differentiation atau pembezaan ni adalah satu teknik dalam kalkulus yang digunakan untuk menentukan kadar perubahan suatu fungsi pada satu titik tertentu. Ia juga membantu kita mengetahui bagaimana suatu kuantiti berubah secara serta-merta terhadap pemboleh ubah yang lain. Formula umum yang kita guna untuk differentiation adalah dy per dx, di mana y adalah dependent variable manakala x adalah independent variable. Okey, seterusnya kita pergi kepada formula lain yang ada dalam differentiate. Okey, yang pertama kita ada chain rule dengan quotient rule. Yang pertama, chain rule ni apa benda chain rule ni adalah bila kita nak differentiate composite function, especially exponent. Okay. Kalau kita tengok formula dia dekat situ, d over dx dalam kurungan e equals to u sama dengan e equals to u du over dx. Macam mana kita nak guna formula ni adalah kita differentiate dulu e tu. Bila kita dah differentiate, hasil differentiate tu kita akan darabkan balik dengan e tu. Okay, seterusnya kita pergi kepada quotient rule. Quotient rule ni kita guna bila kita nak differentiate function yang dalam bentuk fraction. Okay, formula dekat sini kita boleh tengok VU prime tolak UV prime over V kuasa 2. U tu apa? V tu apa? U tu adalah numerator, manakala V adalah denominator. And then mana kita nak dapat U prime V prime tu? Itu adalah hasil daripada kita differentiate U dengan V kita tadi. And then kita masukkan dalam formula dan settlekan dalam bentuk termudah. Baik, seterusnya kita pergi kepada tangent line. Okay, garis tangent merupakan satu garis lurus yang hanya menyentuh lengkung pada satu titik tertentu. Pada titik yang dia sentuh dekat graf, garis tangent mempunyai kecurunan atau slope yang sama dengan lengkung tu. Dalam kalkulus, kecurunan garis tangent digunakan untuk menentukan kadar perubahan serta-merta suatu fungsi pada titik berkenaan. Okey, formula dekat sini adalah y tolak y1 sama dengan m dalam kurungan x tolak x1. Okey, m tu adalah kecurunan, manakala x1 dengan y1 tu adalah point tangent kita. Baik, untuk last kali kita pergi kepada interpretation of derivatives. Okey, tanda bagi derivatif menunjukkan arah pergerakan suatu fungsi. Apabila f prime x lebih besar daripada kosong, maksudnya function tu dia meningkat. Apabila f prime x lebih kurang daripada kosong, maksudnya fungsi tu menurun. Dan apabila f prime x sama dengan sifar, maksudnya fungsi mempunyai stationary point, atau kita panggil dia titik tu di mana kecurangan graf adalah sifar. Itu saja daripada saya. Sekian, terima kasih.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Faris Najmi bin Muhammad Faizal. So next, I would like to present the solution for the industrial drainage tank system. The volume of liquid in the tank is represented by the equation Vt equal to 500 E power of 0.03T minus 15T squared. To determine the rate of change of the liquid volume, we differentiate the function with respect to time. For the first term, 500 e power of 0.03t, we apply the chain rule. The derivative of the exponential function gives us 500 times 0.03 times e power of 0.03t, which simplifies to 500 e power of 0.03t. For the second term, negative 15t squared, we use the power rule. Differentiating this term gives us negative 30t. Therefore, by combining both results, the derivative of the volume function is dv over dt equal to 15 e power of 0.03t minus 13t. This equation represents the rate at which the liquid volume change over time inside the industrial tank. Moving on to the next second problem. I will explain the solution for the concentration in the chemical reaction. The concentration function is given as Ct equal to 15t over t squared plus 2. Since this function is in the form of a fraction, we use the quotient rule. We let u equal to 15t and v equal to t squared plus 2. The derivatives are u prime equal to 50 and v prime equal to 2t. Applying the quotient rule, we obtain the derivative dc over dt equal to vu prime minus uv prime over v squared. After substituting the values and simplifying the expression, we get dc over dt equal to 100 minus 15t squared over t squared plus 2 power of 2. Next, we evaluate the derivative at t equal to 3. Substituting t equal to 3 into the equation gives us negative 350 over 121, which is approximately equal to negative 2.893. The negative value indicates that the concentration is decreasing at t equal to 3. Therefore, at that specific time, the chemical concentration is reducing at the rate of approximately 2.893 units per unit time. So I think that is all from me. Next, I will pass our presentation to my friend.
Assalamualaikum warahmatullahi wabarakatuh. My name is Syahmi Muiz bin Muhammad Nazli. My number metric is AA250460. So today I will explain about the graphical analysis using Desmos for our two application. So first is 3.1 industrial tank drainage system. The graph shows the volume function of the tank together with its tangent line at a selected point. Using the derivative, we can determine the rate of change of the water volume over time. The tangent line represents the instantaneous rate of change at the specific moment, so allowing us to understand how fast the tank is filling or draining. So for the 3.2, concentration in chemical reaction, the graph represents the concentration of a reactant over time. Similarly, the tangent line shows the instantaneous rate of change of the concentration. From the graph, we can observe that the concentration decreases as the reaction progresses, which indicates that the reactant is being consumed to produce product. So now, let's look at the final answer and their interpretation. So for 3.1 industrial tank drainage system, the derivative is dv over dt equal to 15 e 0.03t minus 30t. So initially, the rate of change is positive, meaning the tank is filling at approximately 0.53 time units. The rate becomes 0, which is the transition point between filling and emptying. After that, the derivative becomes negative, showing that the tank is running and the volume decreases more rapidly as the time increases. So for 3.2, concentration in chemical reaction, we found that the derivative is dc over dt equal to negative 2.893. This means that 3 minutes into the reaction, the concentration of the reactant is decreasing at a rate of 2.893 mol per liter per minute. The negative value indicates that the reactant is continuously being consumed from products, which is expected as the chemical reaction proceeds. In conclusion, derivatives are very useful because they help us to determine the instantaneous rate of change in real-life situation, such as monitoring fluid flow in industrial system and analyzing the progress of chemical reaction. So that's all for me. Thank you.
Goo goo gaga. Goo goo gaga. Goo.